Hello everyone. Today we will talk about this effect where we make the player spawn and how we control everything without any lines of code. Because I often see people use libraries like DoTween, for example, to make animations, but Unity already is fully capable of doing animations with the animation controller, and I will show you today the power of that and how we make faster round trips without any code. And even if we have artists in our team, give it to them and let them do the animations and do fancy stuff to make it look good without needing to modify code. For example, we have this effect here where when I play it, the player is currently spawning in. This works with this cut-off height value. So the higher this value is, the more is visible to the game. And we could do something like maybe let him spawn in and despawn him again. So when I copy those over, we have the shader in multiple parts of the model, so for the eyes and everything, so I have to modify the value for all of them. So when I copy this over again, I could maybe have it go to 1 here. And then we have a complex animation where it comes in and goes back and comes in again, or whatever our graphics team or our game designer decides how the animation will look like, or art direction, whatever. They can change that without modifying any code. And I often see in game jams and everything where people come in and add a script to this object where they do tween the cutoff height to do animations like that. And I highly recommend to leverage Unity's animation window to do things like that. Like you just saw, you can add basically keyframes and modify every value you see in the inspector. And there are some tricks with that. For example, when you look at my object structure here on the left side, we have the player, which is modified by the backend or by the player controller where this player is positioned. Because when I do animations, for example, let's take our run animation, and let's say I want to wiggle this object left and right, then this animation would tinker with my position of my player. So what I do is I have a parent object which is getting moved around by our code, but the animation is only happening on a lower object. For example, we have this player body, and as you can see here, it modifies the scale of the object to make this wiggle effect. But when I want to mirror the player because he's looking to the left instead of to the right, I have a parent object which is this mirror transform, and what I actually do by code is I set this scale to -1. Now he's looking to the left and not to the right anymore. But if my animation comes in and modifies the scale again, it would set it to a positive value and he would look to the right again. So I have a parent object, which I call mirror transform, which is just there to make him look to the left or to the right. I could leverage the player for that, but it's personal preference to have a mirror object. And everything below the mirror object can be modified by animations because it is positioned by the player object where I want to have the object, and it's mirrorable by the mirror object. And when I play the animation, you can see it's actually it actually works. When I set the player looks to the right again, then I can play the animation and it will run just fine. There's also another part which I use is I want animations to be layered. So I want players to be running around with the run animation and spawn in. So I want to basically have the spawn in animation and the run animation play at the same time. Unity is also capable of doing that. When we look at my player animation controller, we see I have two layers. I have the parameter for the animation. Maybe I can't press play, I don't know what will happen. Yeah, we don't see that. Let me hide the login screen. So we can see, let me put that down here. We can see the idle animation is playing. And when I give him the trigger spawn, then he should spawn. He doesn't because he is already spawned in. This is configured to not be able to transition to itself. So let's dissolve him. Then the dissolve animation is played, and when the spawn trigger is played, then the spawn animation is played. But still his idle animation is still working fine. That's because I'm using multiple layers. I have one layer for the animation. The character is actually playing. I can set that to 1, which should be... It's not changeable because my code will override it for now. Because I set it pretty much every frame. But else it could also be the run or jumping animation, depending on what my code sets to the animation run and jump. We saw that in the videos before. But still, because I put the other animations on a different layer, I can play multiple animations at the same time, which is exactly what we want, and we don't need any code for that. This is just basic animation controller stuff by Unity. I just wanted to show you that you don't need to write any code to make some animations of values in Unity, and I highly recommend you do them with the animation window and play around with it, because it's actually really, really great. What you can press the record button here. Let's better not be in play mode. You can set it to a position where you basically want to add a frame, a keyframe, and you can press the record button, and when you change something, some values, for example, let's maybe rotate him, I don't know, then this value is added here in the window, and I could move that around and maybe rotate him like that, and maybe rotate him back to 0, and maybe at the start I want this to be 0 also. And now he's also rotating like that, which looks ugly, but you get the idea. That's how you can use this window to basically make all kinds of animations with the values you have in your inspector. And you can remove the properties. So to have not a video which is just 1 minute long, I think it's a good idea to create the shader which I actually use for the dissolve effect with you together. I have the shader in place, which obviously I have it in place because you see it, but let me put that aside. And I think it's a good idea to go with you and create the whole shader and explain everything to you that I do in the shader, so you can learn with me how I do it, and you can see how I build the shader completely from scratch. Let's delete that. Yes, discard and close window. Let's create one which is basically a universal render pipeline because we are using universal, and we have a sprite-lit shader graph because we have a sprite. Let's call it player shader 2 and let's open it. It opened here. Let me put that in. So what we have here is basically the vertex shader and the fragment shader. Unity changed that recently. Before that it was one big quad and everything in there. First of all, let's change the main preview to quad, which represents what we have. And let's load in our texture. So we can add properties here. Let's add our texture, which is the main texture. It actually has to have a special name. It's underscore main text, if I remember correctly, because this texture will be filled with the sprite texture. So when I have a sprite, then main texture is the sprite itself. I picked a default value and we want to sample the texture. That's the easiest shader you can build. You can sample this texture and put that into base color. Now you start to see these artifacts at the border because my image isn't perfect. But what I do normally in my image, because I drew this body, I have the alpha value. So when I put alpha in here, you can see it's cut out. And we just see the body like we used to. So we loaded our texture and we put it in there. Maybe I keep the previews so you can see what's happening. So what we want to do now is we want to create a noise over this texture. So let's put simple noise. There are multiple noise, a Gaussian noise, Voronoi. They look all different and please play around with them. But for now, I will do a really short demo on how I created a shader. So we make a float value configurable called noise scale, and maybe we give it a value of 25. And if you modify this value, you can see it's basically the scale of the artifacts of the noise, and we put that in there. And we make this value, I think it's by default. Yes, it's by default. We make this value configurable. So let's actually select our shader here. So we have shader graph, player shader 2. And it's not configurable though. Oh, it's exposed. So when we save this asset, then the noise scale is modifiable here, like the main texture. This is exactly what we want. So you can disable or enable the exposed here to make them configurable or not. So we have this noise texture, and what we actually want is we want to remap the values. The values of this noise texture scale from 0 to 1. And we want them to be more black and we want to basically scale the strength. So the noise texture is from 0 to 1. So basically in min and in max is 0 to 1. And what we want to have is we want to have -1 to 1. And as you can see in the preview, everything that is black will be, in our case, because we will use it as an alpha cutoff, will be not visible. And everything that is white will be visible. And we can make a value for that configurable, which is noise strength. And let's give it a default value by 1. What we want to do now, we want to have negative noise strength and positive noise strength in X and Y. So we negate it, so it's 1, when it's negated it's -1. And then we put it into a vector 2. So Y will be the normal noise strength and X will be the negative noise strength. And when we put that in, nothing will happen because this is basically the same values I put in there, but we can change the strength of the noise. But we keep it for 1 now. So what we are able to do now is we can, for example, multiply that with our alpha. And then you can see we have this, basically some part of our object not visible and some parts visible again. But we want to configure how much is visible and how much is hidden. We create a float value, which is often called cutoff height, which is basically where do we cut everything off. And what we can do is, the simplest thing we can do is basically add the cutoff height and leverage that. And what we can do now is we can increase the cutoff height, and because it adds to the noise remap we have when we add, let's say this remaps from -1 to 1, so the lowest value is -1, and if we add 2 to that, then everything will be white, and so everything will be 1 or higher. And if that's the case, then everything will be visible for sure. And if we lower that, we have this fade-in effect of the object. So let's keep that at 0 for default. This is basically what we later animate. So the next thing we want to do is use the position of the object. Not of the object in world space, but where we are at the object. So at the bottom we want this faster to be visible than the top, basically. If I see a lot of people using world space, but that's in my opinion actually not a good idea, because world space, then the shader works differently depending on where the object is in world space. So if the object is at the sky, then it's harder to become visible than when it's at the bottom. And for view space, that's actually the same, but in the view space of what your camera is seeing. So world space is in the world itself, view space, and then we have object space, which object space is per object itself. So it's still, the shader is still affected by how big the object is, but we can cope with that. So what we are just interested in the y value of this vector position. So we split the vector, and g is corresponding to y. And what we want to use is a step function. the step function works like this. If the in value is greater or equal the edge value, then the value will be 1. If that's not the case, the value will be 0. That's why we have an in value of 0, and everything that is below 0 in this test object here is 1, and everything that is greater than 0 is not 1. And if we increase this value, the white part goes up, and if we decrease it, the white part goes down. And what we will feed the in value with is our noise texture here. And what we get is basically our noise texture depending on the height of the object. And if we feed that into the alpha value, then we are pretty close to what we want to have. So it's our noise texture that gets more and more visible, so everything becomes more visible, but also because this step function makes the bottom part easier visible than the top part, it actually goes from the bottom to the top, which is basically the effect we are going for. The other thing we want to have is we want to have this edge of our cutout to be shiny and glowing. And for that we create the edge width, which is basically how big our edge will be, and we give it 1, I guess. Let me check the default value. Oh, it's 0.1. It's not that big. Those values you normally play around till you find good values. And we give it an edge color to be able to configure a color for the edge. So let's put a red and definitely make this color HDR. And we make it a shiny red. And maybe give it full alpha value, even though we don't use that anyway. So what we can do, or what we could do, is basically flip those values around here. So when we put this in the Y position into a step, but this time as an in value, and we take our noise as the edge value, then you see we basically get the opposite version of our step function. But we still want to be able to control with our edge width to have them a little bit overlap. And what we do is basically we add our edge width to the Y component and leverage that. And this way, maybe you saw it got a little bit bigger. And to give it a color, we multiply that with our edge color. So now I played around a lot to make this work. So what we can do is we can multiply our base color with our cutout, which, oh sorry, I messed that up. And if we apply that to the color, it shouldn't change too much. It shouldn't change anything because everything that we blacked out isn't visible anyway. So let me just get some space here. So what we can do now, we can add the red color to that color and supply that. Now we have a little bit of red visible. And if we modify the cutoff height, you can see that that's already a pretty cool effect by itself. But I wasn't satisfied with that. The reason is I want the red value to be a little bit more visible. And to do that, it's actually quite easy because we have this alpha cutout and we just need to increase that a little bit. And what I did is I subtracted the edge width from the Y position and feeded our step function with that. So this goes into the step edge, and we take our noise again, and this exposes a little bit more than this one because I lowered the position of the edge. And when I use that for the alpha now, you can see that a little bit more is visible because alpha shows a little bit more than our base color exposes. And everything that is not exposed by our base color will be overwritten with our red color. In our case, we can change this color. Maybe we want to have it blue. And now with the cutoff height, we could modify the position. And with the noise scale, maybe set it to 100 to have smaller artifacts. You got the effect that we just built. And that's how I render currently the player and the eyes and everything with the player, and you can modify the cutoff height to show how the player is rendered. Let me save that asset. I don't know if the animation controller can work with that, because he can actually, which is quite impressive, because I named them equally. Cutoff height is named cutoff height. And we can change it maybe to a blue like we did before. And then everything is blue. Maybe we want to have those bigger. And it's a lot of playing around. Oh, that's actually maybe a bit too shiny, right? Actually, if you have in your project this color HDR and you change the intensity and you're wondering why it doesn't show, the trick is that this intensity, if I make it really bright, this intensity is shown by our post-processing bloom effect. So you need to have a bloom effect to have it show. As you can see, when I disable bloom, you don't see it, because the bloom effect is basically leveraging the intensity to make this glow. That's actually also the only way to make sprites really glow and shiny, is to have, or it's actually an easy way, not the only way, but yeah, maybe that's overkill, but you get the idea, and I hope I showed you a great shader. What we will do to make things easier, if we have different effects, I will always create them in one shader, because I don't like to switch shaders around on the player. I want to have something like an Uber shader, which is able to play every effect we want to have. And that's how we do animations and everything in our game. I hope you learned something. And if you liked the video and you learned something, please hit like and subscribe and ask comments, join our community. I really want to thank you, my Patreon, which is Julian, for making a lot of this possible. Also, I wish you all a great weekend and have a good day. Bye.